Communities of microbes called microbiota exist everywhere in nature, from volcanic hot springs to the deep sea. They even cover our own skin and intestines. They support essential ecosystems, including our own physical and mental well-being. Microbiota may contain thousands or more different species of microbes. The destruction of nature, pollution, and climate change all cause an alarming loss of biodiversity to all types of species, including microbes. Researchers first started growing them on artificial media about 150 years ago in describing their diversity. There are bacteria, microscopic algae, fungi, and yeast. Around 1890, the first collections were founded to keep these cultures alive for future research and use. It is estimated that there are over 100 million different species of microbes, but no one knows exactly how many there are for sure.
What if one of the 100,000 cultures of fungi and yeasts, preserved here in this Dutch collection since 1904, turns out to help to digest plastic waste? It should not be lost before knowing its potential. How do culture collections preserve the microbes? Freezing the cells at ultra-low temperatures, such as in liquid nitrogen, or freeze-drying them to a powder to be stored at room temperature. Microbial cells stay alive, but slow down their activities when frozen or dried in the right conditions. This allows to preserve microorganisms for centuries to come, and to supply them to the community for research, development, and education.
So how do we get the strains?
Well, for example, a citizen science project asked elementary schools in the Netherlands to help discover soil fungi. Soil collection kits were distributed and children sent soil samples from their home or school gardens to our institute. 15 new species have thus far been described and named after the collectors of the samples. To know whether a strain represents a known or a new species, it is characterized on molecular level. With the DNA barcodes, entire microbiota can be studied in thousands of soil samples, even without culturing a single microorganism.
The exploration of microbiota has opened a new field of research. It's already clear that different microbes that live together influence each other and the environment in which they live. A lot of research is now conducted to better understand microbiota's potential. One of the goals is to learn how they may help plant and animal health and fitness. To achieve that, it would be really handy to store microbiotas and to be able to go back to them for isolation of interesting strains or the discovery of new capacities.
However, the preservation of microbiota is not so easy because different microbes react differently to the preservation procedures.
Indeed, a microbiota is a complex community comprising bacteria, fungi, and others. These organisms do not all belong to known species, and for some, we don't even know how to cultivate them. Therefore, the composition of the microbiota after preservation may differ from the original composition and may in turn have an effect on its capacities. We're exploring solutions how to best preserve the survival and capacities of microbiota. This will give us a chance to better know and use the Earth's microbial diversity.
MIRRI, the microbial resource research infrastructure, provides a step forward in biotechnology and bioeconomy by combining microbial collections to real-life innovations.